Hello people, today I'm going to demonstrate how to use Hecras for river modeling. Going to a very basic tutorial on how to get started with Hecras program. Hecras means Hec is Hydrologic Engineering Center and RAS here means River Analysis System. It's a free for such a modeling of flood modeling 1D or 2D. It has the capability of 1D analysis. Today I'm going to demonstrate the 1D analysis. So you open your Hecras program for the first time. You will, when you install it, you will have Hecras program like this. Open it, launch it. There's a very simple window pops up here, and I have also made a presentation side by side that okay. So let me put side by side. So here is and here is the program. Run Hecras, we need data types, that is geometric data, energy loss data, that is mechanics and fraction coefficient, and lastly the flow data. Flow data can be discharge hydrograph, stage hydrograph, and finally boundary control. So with this, let's get started with it. So first thing first, metric data. I have made a very one geometry, hypothetical geometry based on this paper. It is paper by Perumal, fully mass conservative variable parameter by Perumal and price. I channel configuration as they have done it, validate their method. So the input hydrograph is generated from PSN type distribution, this parameters, and these were the channel type. So I will be basically running for 10 with the bed slope 0.01 and manic 6. So what I've done is I've created a hypothetical channel section. You can see this top channel and this is the top cross section, last cross distance between cross section 150 kilometers. Based on this information, I have created the fact I have generated this cross section coordinates. This becomes coordinates, so I've already written it here. So this is the information that I'll be putting across. So let's get started. So okay, so here we see there's geometry and flow, and then lastly there is a description. If you want to put any additional information about regarding your project, you can do so. And if you're opening this Hecras for the first time, your unit could be US unit. So to change that, you go to option, units, then you have to make it national, wish to work in a unit. I'm selecting it. Let's get started with that. So first, let's create a new project. Since I'm going to create a new project, I'm working on a new project, so I'll be project. So I'm currently in document. Let me create a new folder by the name Hecras. Okay, Hecras is already there, so I'll one. All right, now I'm inside Hecras 1. Go H channel 10. So 10. All right, so this is my project file. Great. Just saying project file has been created and unit is unit. So that's it. Here it comes. Project has been. Next is geometry. Create a geometry data, then start by creating geometry data. You see river schematic diagram, so you have to make a river schematic. For that, take a river reach tool, click on two, doesn't matter. Okay, I'm naming this river as ch10 because channel 10. To reach, let's say 1. To reach one river can be of three, four reaches, right? One river can be made into this. Right now we are just give a number, the name also. Alright, so river reach 1 and channel 10 has been created. Now next is cross section geometry. To do so, go to cross section 2 here and go to options, create a new cross section. So it's asking for a station name. So usually if you give a it accepts the number. So if you give a higher number, that higher number goes upstream. So since I'm working 150-kilometer reach, so I'm just 150. So 150 is my top, the first cross section. Okay, 150. So river station is 150. Now station, as you have remembered, it is 0 and elevation is 180. Next is 0, 150. Next was 50, 150. Next is 50. These are the coordinates of my cross section, 50, 180. Okay, so left of bank is 150 kilometers. So unit is in meters. So 150. Copy this here, paste it here. See, this is the left of bank, this is the right of bank. If your river is meandering, then left of and right of this bank distance won't be same. For that purpose, they have given 3. But in our case, we'll just wait. Manning is, as I said, we are going to use 0.6, and it's same for left of bank and bank. So here it says which station is the left of bank. So 0 and right of bank is 50. If you all the informations are inserted, so contraction expansion I'm going to leave as it is. So I'm going to apply this data. You can see cross section appears here. Okay, now this was my first cross section. Now next is, let me create a new downstream cross section. For that, what I'm going to do is copy the current cross section, because everything remains same. I'll just have to make some changes with the coordinates, which I'm going to do it. So river station, I'm just putting it as 1. This is my last cross downstream. Okay, so everything remains same, just changes are is going to be 30, going to be 0, is going to be 0, is going to be 30. So, all right, so if we do so, and left bank is going to be 0, this is 0, this is 0, everything is same. When you apply data, your cross section goes off, because see, we are still in coordinate 150, the elevation is 50. So if we need to come back again, what we need to close this window, and you can see in your geometric data 150 is created, 1 is created. If you go and cross check, this is for our station number. You can see 30 here. And okay, having put one first and the last cross section, this much cross section is not sufficient for us to run this model. So what we do is we have to interpolate the cross section. So tools, interpolate within a reach or between two cross sections, doesn't matter. I'm doing within a reach. So upstream is 150, downstream is 1. Maximum distance, so maximum distance, let's say I'm going to use let's say 10 meters. Interpolate. Unable to create interpolate section between 160. There are only 7 characters by level to interpolate. Try again. Larger interpolate. So if there is something wrong, then it will give some warning. So let's give it 100. Accept. Yes, it accepted. Also at 100 meter it has created the cross section. If you want to validate that, we can go here. As I move down, as I move up, see, cross section is because we have kept some certain slope, right? So these cross sections are, the previous cross section. I mean, if you move from downstream to upstream, the next cross section will be always at higher elevation depending upon the slope. You can see. Okay, everything seems fine. Okay, now let's save our geometry file. So save geometry data. Save geometry data as in the same folder, geometry, geometry of sketch 10, channel 10. Okay, Hecras creates many files, so it would be wise if we one folder separate for separate project. Alright, so geometry has been saved. Now next is geometry data has been saved. So reach length I already have inserted it. Hydraulic structure, since we are not operating any hydraulic structures, so ignore this. Next is energy data, as you already seen many the report contraction expansion. I have just the default values. Now the next is the flow data. Let's go and put the flow data. Close this window. You can see geometry has now appeared. Now uh, edit unsteady flow data, because we are going to run the unsteady flow. Go and say unsteady flow data. So here is a topmost cross section, and this is the downstream cross section. Here, as you click, you can see the options are changing. So topmost cross section, you have three options: stage hydrograph, flow hydrograph, or a stage of both the hydrograph. So since I already have the data so of the flow hydrograph, so I will just go and put the flow hydrograph here. All right, so I'll copy my flow hydrograph, and it is based on PSN type 3 distribution. That paper, I have copied the flow hydrograph, and it is at 5 minutes interval. 5 minutes also, 5 minutes, and paste here. I'll select all the rows and then I'll paste here. So start a fixed date. So if today's time is 0. Okay, so our inflow hydrograph is this. Beautiful. All right, so what we have just done is we have put this into flow hydrograph on our topmost cross section. Okay, we need to note this dates, start time and end time, because later on we need it. It is going to be 18th November 13:15. So but this end date, because later on from which date to which date we want to run, that we have to put it. So okay, fine, 13:15. I have memorized this now. Okay, great. 5 minutes interval, everything is okay. Now downstream, usually downstream we should be putting stage hydrograph or flow hydrograph, whichever is known, but in our case we don't know, we don't even have the rating curve. So I'm simply going to put the normal depth. Actually it is asking the frictional slope, but I don't even have the frictional slope, so I'm going to use the bed slope 0.01. And remember that I'm forcing it to behave like a steady flow at the downmost most extreme cross section, the last cross section. So that's why the last the result that it gives for the last cross section, it not be true, because I'm it to be steady flow, because instead of frictional flow I'm using that slope. Okay, that was for you guys. All right, so we have put all the information. Now, as along with this, we also need to put initial condition. Initial condition means what was the existing flow. So my data is 100 here, put as initial flow initially as 100, file, save flow data. So I'm going to say flow channel 10. Wait, I can close this now. Already saved. So geometry done, flow data done. Now find boundary condition is also done. Now final step is, okay, final step remaining is to run this. So that is plan. So run it. I'm run the unsteady flow analysis. Run. So geometry file is selected. simply have one geometry file. 4 file is also selected. The flow file is just, so I will say new plan. I'll just say run one. Okay, sketch, then run one. Right, one. So right, everything is done. I want geometry processor. I want unsteady processor. Since there is no sediment, I'm not clicking on this, so I'm going to say post process on. So I'm going to computational interval 1 minute, let it be like that, but I want this to be at 5 minutes interval. 5 minutes, this is also at 5 minutes, also at 5 minutes. Right, so let it be one. This computational interval is 1 minute, so let it be like that. If it does not work, then later on we can change. So starting date is, I've set it today, 00000124. Again, the ending date is today itself, and 1315, if you remember that. This is how we put dates in across. We don't put 13 comma or semicolon 15. So this is it. We just run this program. Running. In fact, it has already finished running. Now it is storing the data for post processing. Post processing means you want to see what happened. So if you see this green signal, it means your run was successful. If you see red, then we have to go and check what was. All right. So it is giving us some information. All right. Don't need this. Just close this, and I can go and see what happened. At different level was at. I can go and check what happened at cross section. See this, and let us see this three-dimensional view. Dimensional. Play with this. You can play around with this to give us the three-dimensional. And we are much more interested in this tabular data. Yes, so river station, at particular river station, what was the uh, water surface elevation, what was the velocity, what was the flow area, what was the top width. It is a rectangular channel, so see your top width remains same. It is. This is how we, now if we want to uh, find the particular at a particular cross section, you can also keep the data cross section. But for now, this is how a Hecras simulates. This is it. To go by the rating curve, this is the rating curve generated. If you see some, if the program is unstable, then this rating curve would be, from the look of the rating curve only you can make it out that program was unstable. This looks fine to me. Okay, that's it. Thank you.